Hey everyone, it's Mr. Vargas here. Just wanted to help out my Math 8 students with their homework, 5.5 Pythagorean Theorem. So before we get started, I just want to remind you guys of the formula for the Pythagorean Theorem, and this should be ingrained into your brain by now. Or, if it isn't, you should really take some time to memorize this. And it's just a squared plus b squared equals c squared. Okay, so these are just really generic letters, a, b, and c. You could really use any letters you want, but a, b, and c are the most common for the Pythagorean theorem. What do these letters represent is probably the more important part, or the more important question. So your A and your B are going to be your two legs. So this is your leg of your right triangle. This is the leg of your right triangle. And this, the C, the one that's all by itself, is going to be your hypotenuse. It's a funny word. But the hypotenuse is always the longest side of the right triangle. So I drew a right angle there to symbolize right, or 90 degrees, right triangle. Okay, longest side of a right triangle. Alright, let's look at a right triangle really quickly just so we can identify the leg, and the hypotenuse. So if I had this, and I apologize that it's not perfect, but we do our best. The legs are going to be your smaller sides. So this would be a leg, we can call it A. This will be a leg, we can call it B. And this long side right here, that's going to be called your hypotenuse. Okay, and you'll notice that the hypotenuse is always directly across from your 90-degree angle. So that's something to remember. The 90-degree angle will tell you where the hypotenuse is. It's always going to be opposite of that 90-degree angle. These two angles over here, they're going to be smaller. And they have smaller sides, or legs, opposite of these angles. So this angle is opposite of this leg, and this angle right here is opposite of this leg. Alright, let's look at some problems from your homework. Problem number 1. Write an equation that you could use to find the length of the missing side of each right triangle, then find the missing length. Round to the nearest tenth if necessary. So I'll do number 1. Okay, you've got a right triangle that looks kind of like this, and they tell you this is C. Okay, so that's going to be your missing side, 5 and 12. Okay, it's really important to identify where the right angle is, and that's going to be here, right here. So this side, this long side, is going to be your hypotenuse. So when we go up to set up our equation, the hypotenuse, the c squared, is going to be all by itself. So remember the formula is a squared plus b squared equals c squared, where a is a leg, b is a leg, and c is your hypotenuse. So go ahead and just plug in this information that they give you, a, b, c. I can label that, a, b, and that's my c. Go ahead and plug that in to your formula. So a squared is 5 squared plus b squared is going to be 12 squared, and that is equal to your c squared. Alright, so there's your equation. Now you just have to solve it to figure out what the value of c is. I'm actually going to rewrite this equation over to the left, just so I can show it a little bit clearer. Okay, Okay, so we've got 5 squared plus 12 squared equals c squared. We're really trying to find this missing side length. The missing side length is the hypotenuse, it's the long side. We want to find the value of c. So, you guys know how to do this left-hand side. You can do squares. 5 squared is 25 plus 144, and that's going to be equal to c squared. Okay, we can simplify that even further. 25 plus 144 is 169, and that's equal to c squared. Okay, here's the new step that maybe we haven't talked about a lot, but pretty much we're going to need to undo this c squared to get c all by itself. Remember, our ultimate goal is to get a variable all by itself when we're solving an equation. Now, the way to do that in this case is to do the opposite of squaring. And the opposite of squaring is actually taking the square root of something. When we take the square root of a square, that cancels those operations out, and you're just left with c. But remember, in math, we have to be fair. So whatever we do to one side, we do to the other side. So you actually need to take the square root of 169. When you punch that into your calculator, you'll get 13. So c equals 13. And that's going to be your missing side length from your problem. And that makes sense, right? Since it's the longest side, it should have the biggest value. So 13 inches is the length of c. Okay, let's try number 2. Alright, we've got this triangle going on. Boom. Right angle. Sorry for the terribly drawn triangle. This is going to be 51 yards. This is going to be A yards. So this is the one we're trying to find right here. I'll underline it. That's what we're trying to figure out. This is going to be 60 yards. Okay, so now our equation is going to look a little bit different since they give us the value of the hypotenuse. Okay, so when we go to set up our Pythagorean theorem, we have to make sure we plug in A appropriately. I'll label this as B and this as C. We have to set this equation up appropriately, otherwise we'll get the wrong answer. So remember, it's leg squared plus leg squared equals hypotenuse squared. So here we go. A squared, because we don't know the length of this side, plus we do know what B is. B is up here for us, 51 squared, equals, and this time we actually know what C is. We know the hypotenuse, so that's going to be 60 squared. Okay, we've got our equation. We've got one variable, so let's solve for that A. And I'll do that over here. Let me rewrite the equation. A squared plus 51 squared equals 60 squared. Okay, go ahead and solve that out. 51 squared, we can do that multiplication really quick. Okay, so that's 2601 equals 60 squared is just going to be 3600 plus A squared. Alright, since we want to get A all by itself, I'll draw my wall here this time around. Since we want to get A squared, or A all by itself, we have to subtract or do the opposite of whatever is bothering it. So I'm going to subtract 2601, subtract 2601, and that gets you A squared equals, do some borrowing here, so you get 9, gotta borrow again, 999, there it is. Alright, and now the important part here, remember to find the opposite of a squared, or to get a all by itself, we're going to do the opposite operation of squaring, which is just the square root. And that will cancel out your squared, and a comes out of jail free, all by himself, which is what we wanted. Okay, whatever we do to one side, we got to do to the other side. So take the square root of 999, and I believe when you punch that into the calculator, you get 31.6069 ... It goes on forever. So in the problem, they ask us to round to the nearest tenth if necessary. So I find my tenths place, I go over to the right one, and that 0 is actually going to tell us to stay the same. So A is approximately 31.6. And that's your answer. So going back to that triangle, over here, your missing length for A is 31.6 yards. Alright, there you go. So the rest of the questions on the homework are really just centered around this idea of the Pythagorean Theorem. So I'm just going to remind us once again what the formula is. It is a squared plus b squared equals c squared. And just remember that your a is your leg, small side of your triangle. Your b is another leg. And these are kind of interchangeable, doesn't really matter, since you're going to have two small legs. And then c is your hypotenuse. And that's your long side. Okay, so if we were to draw that picture again, I could do, let's see, something like that. There's a right triangle. This would be a leg right here, A. This could be a leg B. And this would be C, your hypotenuse, your long side. I will go over number 4 really quickly, just because that one might get a little bit confusing. So here they're asking you to justify whether the sides of a triangle can make a right triangle. And if we can make a right triangle, this always has to be true. Always. If you have a right triangle. So here we're going to assume that the sides are 28, 195, and 197. We're going to substitute those into our equation, and if it holds true, then it's a right triangle. So let's go ahead and set that up. If it's true, 28 squared, since that's a small side, plus 195 squared should equal 197 squared, your long side. So once again, your two short sides squared, add that together, should equal your long side squared. I'm just going to go ahead and use a calculator here. 28 squared is 784. 195 squared is 38,025, and that should equal 197 squared, which is 38,809. Okay, when I add 784 plus 38,025, sure enough, that adds together. You get a sum of 38,809. And since that equals the right-hand side, this is true. This is true. True. These side lengths, 28, 195, and 197, are appropriate for a right triangle. Shout out to my Math 6C class for putting up with me while I made this video. Have a nice night. See you next time.